give a brief summary of what we did in Lab 2. In Lab 2, we use AWS. We create 3 instances to simulate router, client, and server. Then we use iPerf and iPerf3 to test the bandwidth between the networks between them. And we're going to quickly go through all the configurations we did. First, we created 4 subnets. We name it from subnet 1 to subnet 4. Then we created internet gateways, which allows us to access to public internet. And we attach the public gateway to our VPC. Then we set the route tables. We allowed all the default destination IP to route to the internet gateway we created, and all the subnet IP to local server. Then we created 3 elastic IP addresses, which allows us elastic IP address or static IP address, which allows us to SSH into our instances. Then we created 3 instances. We named it router, server, and client. All the instances we created, we allowed all the TCP, ICMP, and UDP protocol from all ports and all default IP addresses to access. Then we should associate our elastic IP address with our network interfaces. We created 2 network interfaces for each instance, and we associate to one of them. Then we're going to SSH into the instances. To save time, I have already tested and SSH into our instance. And I'm gonna show one of it. That's how you could SSH into it. First, we're gonna set our private key to public visible. Then we could SSH into our instances. It takes 2 seconds. Okay, it works. Then we're gonna test the routing table between routers and client and server. First, we check the route tables in our server and our IP and our client instance. And we're gonna delete the IP, the route I already added to see what could happen. And we're gonna ping the IP address of the clients. And see if the route could receive the package we sent it. The router did not receive the package we sent it, which means the package did not pass the internet interfaces of IP of router. Then we're gonna add a route. And we're gonna try it again. And now we could see packets pass through the interfaces of router. Okay. Then we're gonna test the bandwidth between a client and server use iPerf. And we do not need the router. We start iPerf on our server. And first we're gonna test the bandwidth of UDP. And we're gonna use the IP address and we're gonna send the bandwidth. First we're gonna send to 500 megabits. And as shown in the graph, the largest speed of packet transfer would be 96.8 megabits per second. So I'm gonna shrink the bandwidth to 100. And now the loss of datagrams decreasing tremendously. Next, we're gonna try TCP. We just delete the configuration of -u, which means UDP. And we could see the bandwidth, which will be 95 megabits per second. Then we're gonna go through different scenarios. First, we're gonna set the delay to 100 millisecond, microsecond. Oops. It seems that we already configured it. So I'm gonna first delete all the configuration. Then I'm gonna do it again. And now it works. Okay. Same first, we're gonna use UDP. And it has almost no impact on UDP. Then we test TCP. you could see that TCP, the bandwidth of TCP decreased. Then we set the delay to 0 milliseconds and introduce random loss of 10%. And now we could see with the introduction of packet loss, TCP, bandwidth of TCP decreasing tremendously. And we're gonna see UDP. And for UDP, it may have certain impact, but not much as TCP it does. And we're gonna clean all the configuration we did. And we set the largest transfer rate to 1 megabits per second and the latency to 1 millisecond. And we set the burst to 9,000 packets. For UDP, it works well. And for TCP, seeing that latency of 1 millisecond do not have much impact on both of them. Then we try to set the interface to speed 10, and it shows that we could not get current devices settings, which means that AWS has already set it, that we could not set it. And I think that's pretty much of our labs.